Hello, my name is Christopher Kennedy, and I'm going to be talking about stem cells. Now, because stem cells are not a disease or condition, and rather a treatment for those, I'm only going to be talking about some basic information, a couple of the different broad categories of stem cells, the treatments that we have at our disposal today, and then taking a brief look into the future of research with stem cells. Start off with some of the basic information. Now, for a cell to actually be considered a stem cell, it must meet two main criteria. The first of which is that it is an undifferentiated cell. This simply means that is a cell that does not have a specialization just yet. As you can see with the image on the right, stem cells have the potential to develop into specialized cells, such as muscle cells, liver cells, or nerve cells throughout the body. The other criteria for a cell to be considered a stem cell is that it may divide indefinitely while maintaining this undifferentiated state through the process of mitosis, just like every other cell in our body. Although there are many specific types of stem cells, each of which carrying their own potential treatments and research specific to that one area of the body, there's only two broad categories that we're going to be talking about today. The first of which is embryonic stem cells, the second of which is adult stem cells, and I'll be talking a bit more about that later in this presentation. Stem cell therapy is the use of stem cells as a treatment for these diseases and conditions, and they have different applications of how they actually apply the treatment. Again, I will be talking about this a bit more later in the presentation. So the first category that we're going to be talking about is embryonic stem cells. Embryonic stem cells are obtained from a blastocyte, which is a structure that holds the intercell mass, and this intercell mass is what eventually develops into the embryo. Embryonic cells are pluripotent. Now, what pluripotent means is that these stem cells can form into any cell type in the body, no matter what a general specification is or what very exact specialization it has after determining whether it's going to be some type of blood cell, some type of muscle cell, or what have you. The only limitation to pluripotency is that they cannot revert back to an embryonic cell. So, like I said, embryonic cells have a great potential to develop therapies for genetic disorders and cancers specifically. Genetic disorders in particular can many times be traced to early development in embryos, so the research through using embryonic stem cells might give us a much better look into how we can identify those genetic disorders early on, or how we may be able to treat them altogether. Furthermore, from genetic disorders, embryonic stem cells are a great research tool in understanding early human development. One of the very specific types of stem cells that show up in embryos are called extraembryonic stem cells. Through research in mice, we have been able to see that these stem cells eventually aid in the formation of the heart. So if we were to do a lot more research with extraembryonic stem cells, we might be able to look at how the heart forms early on in the embryonic development. Now, with embryonic stem cells, there's a great moral controversy at hand. Obviously, because of them being embryonic, it means we have to get them from embryos. Now, developing embryos simply for the purpose of research, especially human embryos, becomes a great human's right, or possibly an abortion issue, which is out of the scope of this presentation, but it should be mentioned for the limitation it puts on potential research. Now, the second category of stem cells are adult stem cells. Obviously, these stem cells are going to be found in the body much after development of the embryo into a full-on human body. Adult stem cells, unlike embryonic stem cells, are multipotent. Now, multipotent simply means that they have the potential to develop into very specific areas. However, they cannot go into every possible cell in the body. An example of this would be something with bone marrow. So bone marrow is actually something in the body that is highly concentrated of stem cells. However, these stem cells are only going to be able to develop into certain types of blood cells. they've already gone through part of this lineage into becoming a specific blood cell, whether it eventually be a red cell, a white cell, or whatever. They cannot become muscle cells because they've already started along this lineage. Now, therapies with adult stem cells are obviously going to be very specific to the organ because, like I just said, something with bone marrow is only going to be able to develop into blood cells. Then we can only use bone marrow for blood diseases, stuff like this. Adult stem cells also have the potential to regenerate organs and repair damaged tissue in the body. I will be talking a little bit more about this later, but the main concept to know for now is that these, because they've already started among some lineage, they can then form with the cells that are already there and adapt to those to regrow tissue that is already damaged. The hiccups in research are not on the moral controversy side with adult stem cells. However, harvesting enough adult stem cells for sufficient research becomes a challenge. The main way we get adult stem cells is donors of specifically bone marrow. However, this is a rather painful procedure requiring drilling into either the femur or iliac crest. At least those are the two most common places. And because it is a very painful procedure, you don't have people lining up to go donate these bone marrow and other adult stem cells. Now, the first type of stem cell therapy at our disposal today is hematopoietic. Now, it's a hard word to say, but it basically means blood-related issues. So, like I talked about earlier, bone marrow transplants have long been one of the primary hematopoietic therapy at our disposal. The bone marrow stem cells can help rebuild different cells in the blood system, as well as help treat specific blood cancers such as leukemia. However, recently the FDA has also approved treatments using umbilical cord blood for blood and immunological diseases. The use of cord blood helps to treat diseases such as leukemias and lymphomas. Although it may sound disgusting because we're having to get it from the umbilical cord, this is actually a lot cleaner of a process than using bone marrow. Because the blood is harvested after the child is born and after the umbilical cord is cut, it is also a much safer and practically no harm to both the parent, or the mother, and the child. The second type of stem cell therapy that we have at our disposal today is grafting. Now, grafting stem cells is basically a tissue implant. So stem cells that are implanted into the tissue adapt with the host tissue and help to rebuild those damaged cells, or if it is a specific disease, helping to get those cells to where they actually should be. Grafting therapy is most generally applied to the skin, although it can also be applied to the bone and outer layer of the eye. This therapy is used as a treatment for genetic disorders as well. A recent case saw a skin graft of the entire body, helping to treat a child with a severe case of epidermolysis bullosa. He ended up recovering fully and is not dealing with this as severely as he once was. This image is a before and after of both a hot water scald and electrical burn, showing the potential for grafting to treat damaged skin tissue. Now, there is some side effects with stem cell therapy. Low red and white blood cell counts are often seen after treatment. Low red blood cell count can lead to anemia, whereas low white blood cell count means that the patient is at a high risk of infection because the body cannot properly defend itself. Another major complication with stem cells is grafting versus host disease. Now, what grafting versus host disease means is that the cells that are implanted into the body see the host as a foreign body and end up attacking it, obviously creating complications for the person. Other common side effects are loss of appetite, sickness and diarrhea, and feeling of tiredness. Stem cell research is a relatively new subject. Stem cells were first discovered in the early 1970s, and as we've gone forward with it, there's been a huge difficulty to actually thoroughly study the effects of treatments, especially in humans. A lot of the research we do will be in similar other animals such as mice and many primates. However, this does not always translate exactly as we'd hope it would to humans. So finding reliable therapies with humans has those advancements have been greatly slowed down because of the difficulties with research. Now, new stem cells are constantly being discovered. Like I said earlier, there's a plethora of very, very specific stem cells. And we're going to keep looking into those possible applications with each specific stem cell. However, again, we're going to have a huge difficulty in actually being able to get to a safe therapy and thoroughly vet whatever research is coming out of this. Thank you for listening to my presentation. I hope you enjoyed and learned something new about stem cells.